Well, hi there. Thanks for tuning into my YouTube channel. This is the CNC Dude. My actual name is Jose Quiñones, but cncdude.com is a website that I'm going to try to start putting together with information on CNC stuff. I think today I would like to get started with the basics of the Tormach PCNC 1100 and probably answer an eon-long question that has gotten quite heated over the years. And the question is whether it is better to have a CNC milling machine or manual milling machine if you are making, onesies or twosies. Obviously, if you're going into production, CNC milling machine is going to be far superior to a manual milling machine. But if you're just for hobby, making one part, or just facing some material, what is better? And for me, I can tell you that when I acquired this in February 2011, the first time I powered this up, I started wondering whether I should have acquired a manual milling machine because this seemed a little bit overwhelming. So for 15 minutes, I agreed with the notion that a manual milling machine is better. But once you start getting into this, you realize, man, I can do anything that I can possibly think of with a manual milling machine, but more. So I think manual milling machines will become something, museum material in a couple of decades. And every now and then you may find something that you can do a little bit quicker with your manual milling machine. For the most part, this is as good as the manual and better. So first thing I do when I go into my, if I have anything that I want to mill or whatever, something I want to work, first thing I do is I turn the computer on. Obviously, a CNC machine without a computer is not a CNC. I mean, CNC stands for computer numeric control, so it has to have a computer of some sorts. And while this guy is booting up, I'm gonna release the emergency stop, turn the machine. Now the machine is really not enabled. I mean, it's on, but it's not enabled because the way that these guys work is that you want to disable everything for safety purposes. And I mean, you don't want this to start all of a sudden and maybe my hand is in there and then we have human-based hamburger meat. Not fun. Okay, so the computer is up. This is a Windows XP computer, so pretty much obsolete by now. But it's all that I need really. There is nothing in here other than Mach 3. I don't use it for anything else. I don't do camming, I don't do CAD. It's a super cheesy computer. It's not really even that fast, but for all it does is run Mach 3, so it's fast enough. So I'm gonna click here on my Mach 3 PCNC 1100 profile, and the Mach 3 is gonna come up, but still nothing happens. The machine is under reset, emergency mode. So when I flick the reset, bam, now the machine is alive. So now I can start moving. I can begin my keyboard keys, and I can move in X, Y, Z, or I could use dependent. This is what is called dependent. It's an USB contraction, and you can use to select an axis and move in that axis. The beauty of this, obviously if you had a manual, you will be moving your handles. So in here you don't have handles, but you have dependent, and you have different speeds. So I can go very slow. I don't know if you can hear it. Obviously you cannot see it, but there are different speeds. And so depending on stuff that I do, sometimes I want to go slow or I want to go fast. Another thing that I could do is actually type in G-code commands on what is called the MDI, the manual data input, I guess. And so for example in here I could say, let me zero everything here, right? So I'm gonna zero everything. So, and there'll be another video detailing stuff regarding the coordinate systems, but that could be a single video by itself. So let's just agree that is 0, 0, 0, and to the machine it is 0, 0, 0. I'm looking here at the DRO. That's the beauty of this thing. This is very similar to when you have a manual machine with a DRO, but you have to move your handles to get there in here. all you have to do is type in a command. So let me get it out of 0, 0, 0, right? I'm going to move it out of 0, 0, 0. I don't know, some X, some Y, some Z, whatever. So the machine is out of 0. This is the distance away that it is from 0, 0, 0. And if I want to go to 0, 0, 0, all I have to do is type in G0, that's the G code for moving fast, X0, because I want to move to the coordinate X equals 0, Y0, C0, and bam, just as soon as I hit enter, it will go there. Now, if you try to do that with a manual machine, you're going to need some kind of a jig on your knee, so that you can do something like this on your knee. And I actually hit my hand pretty hard. Now that's how fast it went to 0, 0, 0, XYZ 0, 0, 0, and all I had to do was press enter and it went there. There was no need for me to wait or do anything with my hands. If you wanted to try this with your manual milling machine, you may have needed, you know, some kind of a jig in your knee, and maybe you have to be like doing something like this, kind of dangerous. You may lose your balance, and so plus, I mean, you're not even going to get the same level of accuracy. But that's one way in which I use the machine. Now let's do an example in which I'm going to cut a piece of aluminum and then we're going to face it, and I'm going to show you how I use the manual commands and the DRO to get the level of precision that, I mean, any milling machine can do this, but it's so easy with a CNC milling machine. Okay, I just have here a piece of scrap aluminum. This is nothing that I would use. I mean, it has holes. I may be able to use some pieces, but I mean, just a piece of scrap aluminum. And I'm measuring, and it says 4.165 mils. I mean, 4.165 inches. So, what if I wanted to cut this so that it was perfectly 4 inches? Obviously, I have to remove 165 mils. So let's put it on the vise and see how we do that. Okay, not necessarily the best angle, but basically what I want you to be able to see is the vise area, the cutter area, and the DRO, so that you can see what we're doing here. So I'm gonna cut this side, and I want to make this length here 4 inches. According to my caliper, my cheapo Harbor Freight caliper that I usually get for 10 bucks. So chances are this measurement is not the best, but 4.165 or something like that. Not certain if you can see that. Hopefully you can. And I'm gonna take it down to 4. So, you know, if you had a milling machine, a manual milling machine, a way to do this, if you don't want to use dials, is you get your caliper and you put this on 4, and, you know, let's see, they're close enough, and then you just scratch it like this. And you may want to use some dye, you know, or some Sharpie. And of course, you won't be able to see the line in there, but that's your 4. And I'm going to show you how you do it with a CNC machine. So we're going to put it here, my vise, my cheapo vise. This is a vise that I bought on the Craigslist shortly after I bought the machine. This is literally Smithsonian material. I'm not supremely proud of this vise, but you know, it works and it does what I'm supposed to do. So I'm going to leave a portion out of the vise because that's what we're going to cut. And of course, I'm not trying to cut the vise. I'm going to secure it. And where's my rubber hammer? This is a technique that I learned from Tom's Techniques. We're working here trying to make sure the tool is as far as possible. Okay. And that's what I hate about this vise. The part never, I mean, I can move the parallel. So this is junk. That's good enough. This is not, we're not trying to develop alien technology here or aerospatial parts. Okay, so I'm gonna move this away. I want the tool to move that way. One thing that you gotta learn once you get this is that the table is not the one that is moving. What is moving is the blade. It is like Einstein said once: when you're walking, is to the eyes of an alien, it may look like you're standing still, but the planet is moving below you. So although the stepper motors are moving the table in X and Y, what you have to think of is the referential frame in which the table is still, but the tool is moving. So if I want the tool to move that way, I need the tool to move in X negative. So I'm going to press X negative. Okay, I'm moving X negative. The same happens with C. If I want it to go down, down is C negative. So Z negative. Of course, let's put a tool that I can use. I mean, this chuck is not going to cut anything. You know what? I'll be back because I forgot that I have to turn on my compressor so that I have enough juice to power my my quick release. Okay, I'm back, and I have already changed the tool. The power dropper needed air, so but that's complete now. So I'm using this end mill, which is really not good for cutting on the bottom. It's pretty messed up. Most of my tools get pretty bad because I really don't know much about this. So unfortunately, it's a learning experience. But for the sides, this is going to cut beautifully. Now remember, what I want to do is get this to 4. So first thing I'm going to do, I'm going to turn the machine, the spindle on by pressing F5. And right now it is set to 250. So 250 is obviously too slow. I'm going to take it up to like 1500. Okay. I'm going to move it on X, and I'm going to cut a little bit of material on the Y axis. Okay, so let's do a little bit of X. And now I want the tool to move into the X positive. A little bit there. Now I'm going to go in Y. Actually, I have started from the other side to do conventional milling. Conventional milling. This is a little bit, that is okay. I'm going to move a little bit more next. I'm going to turn it off, and I'm going to move the tool away because I'm going to take a measurement, and I don't want to be close to that mill. It is in bad shape, but it still cuts like a freaking blade. Well, it is a blade. Okay, so we can carefully get rid of some of this junk here. And I'm going to take a measurement. Now, notice that I didn't move the blade away from X. I could have moved it from Y. It was okay, Y or Z, but not X, because right now the edge of this end mill is the edge of this piece. So that's important. As I measure this guy, the caliper tells me that this measures 4 inches and 148.5 mils. Okay, so let me measure that again just in case. Yeah, 145.5. 145.5. So I'm going to put that in here. That is the measurement where X is. I'm going to say minus 4.1445. Now I had to put minus because remember, the blade is on the negative side of X. This is 0. Somewhere in here is 4, but minus 4 because this is 0, minus 4, minus 4.1445. Okay? Sure. I got this wrong. It's minus 4 1.1455. Okay, 145.5. So now, as I take further cuts, I can monitor this number here, and when I get to 4, this piece is going to be measuring 4. Let's take a look. Probably use coolant. Now another thing that I could do is call that point Y0, and when I move this way, I am on -5 now, so I could say, to go back to 0, I could say G0, Y0, and then I don't have to manually be moving the pendant, okay? So let's take another cut next. I'm going to take it down to -4.1. I move positive. By the way, I could have typed in G0 X minus 4.1. Let's go back. G0, Y0. I'm going to turn off. Move my tool away because I want to take just as a sanity check. The system says that this border should now be at 4.1. So let's see. It says 4.109. That must be because of the deflection of the tool. 4.105, 4.106. Let's do another run. So there was a little bit of material removed. .102, and it says here 4.110. So clearly this is not square either. So actually, let's take this part, invert it, and we'll do this again, and we'll get it better. We still have 100 mils left. So we have to start basically because this is not 4.11 anymore. I mean, I don't know what that is. It's actually pretty far away. We'll take a little cut. According to this is 4.095. Yep. Now both places are 4.095. So I'm gonna say this is minus 4.095. Okay? And now we're gonna start cutting until we reach 4. Now I'm gonna cut until I get only 10 mils left. That's gonna be the finishing cut. Let's do one last check, sanity check. For 0.1, for 0.095. Yeah, pretty much for 4.01. So we are on track. Now I'm going to remove the last 10 mils. And you know, I'm using the pendant, the step-by-step function. I should be a 4 right now. So let's take this out. I'm going to take it back to Y0. I lost my MDI. That happens every now and then. I don't know why. Well, let's do this by hand. Yep, it's gone. When that happens, you pretty much have to restart Tormach 3. Very rare, but it happens every now and then. Especially when you're recording videos and you look like an idiot. It's perfect Murphy's Law. Let's see if it's gone. Okay, I'm going to do one more cut. One more pass, I mean. Just to ensure that I have cut everything there is. Okay, that's it. This is supposed to measure 4 inches now. .000 3.9985. So that pretty much tells me that the vise is not perfectly aligned, and I mean, it's no big deal. Definitely I have to take care of it, but for showing how something works, it's still good enough. Certain if you can see that in there. 4.0. Pretty good. And and this is the finish. It's pretty decent. This one looks, I may have gone too fast on this one. This will require some sanding. This one looks pretty good though. Fortunately, there's a freaking screw hole in here, darn it. Alright, I think this is a good introduction to how you can use a CNC milling machine as a manual milling machine. This was just a simple thing. I mean, we'll get more complicated stuff as we go along. I'm a little bit disappointed that Mach 3 crapped out and the MDI stopped responding. It's a known feature, should I say bug, and you know, it's very rare. It only happens when you're filming a video and you look like an atom fool in front of millions or billions. And the solution is to basically restart the application, which is not a lot of fun if you're like in the middle of something. But you know, hopefully they fix it sometime. Well, like I said, this is a very simple process when you're like preparing the part to actually get something done. Not necessarily what CNC is all about. It's actually quite boring if you ask me, but sometimes we have to do it just to get something clean and ready for something a little bit more exciting. But it's a good introduction to Mach 3 and how to get around the CNC milling machine. So we'll get more complicated as time goes on, and you know, we'll talk about coordinate systems and how you position your part and how you find the edges and so on. Thank you for tuning. I hope you have found some of this information useful. Feel free to comment and tell me what I did wrong and how I can improve. And there will be more videos to come. I'll try to make them as entertaining as possible without having to harm myself in the process. But definitely more videos to come. So keep tuned. Thank you for watching this one.